Hello everyone. In this short video I will go through the basics of algorithms and Python programming. So to begin with, we will first of all define an algorithm, which is a finite sequence of well-defined instructions which are able to solve any problem. To simplify this, you can say an algorithm is just a procedure that we follow in order to complete any given task. For example, if I am making tea, so the steps that I follow from start to the end, the ingredients which are required, those are all included in the algorithm. And the actual steps that we follow, they follow a certain pattern, a certain sequence through which we are able to complete the job. So a good algorithm has a finite number of steps and they are unambiguous. That means that every step should be clearly defined and it should give us correct results. And then the algorithm should terminate as well. That means it should have an end point as well. So how do we represent algorithms? So there are different ways. We can use pseudocode, we can also use flowchart. So pseudocode is a text representation of an algorithm and flowchart is a graphical representation of an algorithm. So pseudocode, for example, if we want to calculate the average of two numbers, so the actual calculation step is very simple. We can just add the two numbers and divide them by 2. That will give us the result. But when we are talking about algorithm, we must include some starting step, we must include some stop step as well. And as soon as we declare the start and stop points, we must clearly identify what are our variables which are required. Because when we are writing an algorithm, we don't know what the inputs will be. So if I'm calculating the average of a number, I don't know what the average of two numbers, I don't know what the two numbers are when I'm writing the algorithm. So for unknown quantities, what we do is we follow the mathematical pattern, we use variables to represent them. So variables like x or y or z, we can name them anything we want according to our requirement. So if I want to calculate the average of two numbers, the first thing I will do is I must have a start and the stop point of the algorithm. And then I can define how many variables I need for calculating the average of two numbers. So in this case, there will be two variable inputs and one output variable. And as soon as we have declared the variables, what we will do is we will get the input. What the input operation means is that, okay, once we defined a variable, I need to put something inside. So variable, you can think of it like a black box. What's inside is the value of that variable. So just like a calculator, when you turn on the calculator is waiting for you to type a number. So whenever you type a number, that will be given to the first input of the variable. And similarly, we give the second input. So once we have the two inputs, after that what we will do is we will add the numbers, divide them by 2, and we will get our result. And after that, at the end, we can display the average result. The same thing can be represented through a graphical diagram as well, which is called a flowchart. So in a flowchart, we use different symbols to represent each step of an algorithm. We use the oval shape to represent the start and the end points. We use parallelogram whenever we are going to acquire or to get input for a variable. The rectangle symbol, we use it for calculations. Whenever, for example, I'm calculating sum of two numbers or calculating the average step, I can represent it in a rectangle shape. Similarly, the diamond shape, we will see it later, it can be used to make decisions. Whenever you have to find out if something is greater than another variable, or whatever decision we want to make in the form of true or false, we will have branches. There we will use the diamond shape. Similarly, we have the hybrid shape whenever we want to display the results on the screen. So the same algorithm, where I want to calculate the average of two numbers, I can represent it in this flowchart where we have the start and the end points. We have the two parallelograms which are used to receive input from the user, and once we get the input, we can calculate the average and then display the output. Now the next step which comes after writing an algorithm is the implementation. So if we talk about computer systems, if we talk about computer science, the implementation is done with the help of a programming language. So Python programming is used in this course to implement the algorithms. So Python is a high level programming language. So what does this high level programming language mean? So programming languages, and remember, computer systems, they understand basic machine language, which is in the form of ones and zeros, on or off switches. So that language which the computer system understands, that is called the machine language, or we call it computer instructions. But these languages, they are difficult to write. We cannot easily write instructions in machine form where the instruction will look something like this, 101011, something like this. So this will be very difficult for us to provide any instruction to the machine. So what we do is we have an intermediate language which is called assembly language. So in assembly language, what we do is whenever we want to, let's say, add a few numbers, or if I want to calculate average, so what I will do is I will write instructions like this. I can say that sum num1 comma num2 comma average. So what this will do is it will calculate the sum of numbers 1 and 2 and put the answer in the average variable. And then after that, what I can do is calculate the average value, which will be dividing the average by 2 and saving the result back to the variable average. So here in the assembly language, although it makes a little bit of sense, but still it takes a lot of time to write basic instructions. So what we do is we have high level languages. In high level languages, what we do is we write instructions in very simple format that we can understand. If I want to calculate the average, I can simply say by writing a basic command, that is average is equal to num1 plus num2 whole divided by 2, but I have to put the brackets here. So in high level language, we can write instructions which are easier for us to write, which are easier for us to understand also, but the computer still understands only the machine language, which is in this 101 format. So what all these high level languages have is a compiler or an interpreter that is responsible for converting the instructions that we have written into machine code. Compiler, what it will do is it will scan through the whole program and then convert and make machine code. In case of an interpreter, what it will do is it will go through line by line. It will go through the first line, convert it to the machine code, execute it, and then it will keep on doing on this way. So interpreter basically executes or converts the instructions into the machine code at the runtime when you are running your application, while the compiler will convert to machine code before actually running your program. Now, how do we write the programs? We have to follow a certain what we call syntax. So what is syntax? Syntax, just like in English, when you are writing statements, you need to know two things. One, you need to know the vocabulary, you need to know the grammar. Syntax is basically the grammar of programming languages. So you need to know where to put the spaces, where to put the brackets, where to put the dots whenever you are writing programs. So okay, so for Python programming, what you need to do is you need to have a Gmail account, and what we are going to do is we are going to use Google Colab. So this is the link, colab.research.google.com, or you can just search in Google that Google Colab. It will give you this link also. And once you open this link, you need to sign in using your Gmail account, and once you have signed in, you will start with a new notebook. So this is where we will do our programming. Now, So once again, once you open the Google Colab, we have the main window here, the work area. This is where we are going to write the code. We can create a new code block. We can create a text block also in our code, and then we can have different access menu here. So here we can provide the basic table of contents, whatever things we want to do. Similarly, we can list the variables that we are going to have in our program. I will talk about them in a few minutes. Similarly, we can also put files, our custom files which we need, we can place them into this folder as well. But for now, what we are going to do is we are going to start and see how we can create variables in Python programming. So if you talk about Python programming, so here first of all we are going to print a hello world text. So here we are going to use a function. So function, mathematically we define them y is equal to f of x. So what does that mean? That means function is like box where we give input and it gives us output without worrying about how the calculation is performed. So in case of programming language or in Python, how we represent function, this f is replaced with the name of the function. For example, if I want to display something on the screen, I can use the print function. And the inputs, they are given inside the bracket, inside the parentheses. I provide any input that I want to present on the screen. So for example, here if I want to print, I can use the statement print with the bracket open, and inside if I want to display text, I can write with the quotation marks. So the single quotation mark, I can use that once again to show you. The quotation mark is located on the left side of the enter key here, and the parentheses shift +9, you can open and close the parentheses. So here if I type the text hello world, or I type hello PYP002 students, so what will happen is that when I press the play button here, it will go through the interpreter and it will show me the result for this statement. So here if I play this, so here you will see I will get the result hello PYP002 students. This will be my output. So that is how you can display results on the screen. Then we talk about the variables. So variables in case of computer systems, if you remember, in case of computer systems I showed you that the computer system memory consists of different blocks, and each block, the size of each block was 8 bits, or which is basically 1 byte. So what is a variable in case of computer systems? A variable is a named piece of computer memory. So that means when I define a variable, that means I'm basically reserving a block inside my memory and I'm giving it a name. So if I say I have variable x and I am reserving this block for the variable x, so that means that whenever I assign something, so whenever I say x is equals to 5, that means I am putting a value 5 inside this block. So simple variables, they can hold only one value at a time. That means if I write a statement like this, x equals 5, I do some work here, I do some work here, I do some work further, and then after some time if I do this, x equals x plus 7, so that means the new value, before it was 5 here, so the new value will be 5 plus 7, that will be 12, will be the new value of this variable x, and the old value will be erased, it will be gone. So from this point onwards, whenever I call the name of the variable x, we are going to use the up-to-date value, which is 12. So that is the variables. The basic variables can hold only one value at a time. So here the same example is given. We have two variables, 7, x and y, which are given the initial values 7 and 3. And when I do x plus y, that means 7 plus 3, 10 is the new value of the variable x. So x will be replaced from 7 to 10. And this value will be used from this statement onwards. So here in the next step, if I do x minus 2, so I will not use the old value, I will use the up-to-date value. 10 minus 2, that is 8, will be the new value of the variable y. So that's how the variable values they change. Now what type of variables we can have? So the type of value which is inside a variable, that defines what is the data type of the variable. That means what type of data will be stored inside the variable. The data can be a number, it can be an integer, whole numbers, like that. It can also be a real number. So a variable can also store real numbers, or it can also store text. So simple numbers, in case of Python, they are represented with the data type int. We indicate the sentence int or the keyword int to represent variables which store integers inside them. Similarly, if a variable stores a real value, the real value data type is represented by the keyword float. So real numbers, for example, the ones which have decimal points like 4.5, 4.6, and integer numbers like 5, and then we can also have text like PYP002. So text data type, that is basically represented with the keyword str. So to give you an idea about this, I will just show you here a very basic example. So instead of printing some text here, what I'm going to do is I'm going to define a variable. So this variable, I will first say it's equals 5, and if I try to print this variable, I will get the output which is 5. But if I go to the variable information, you will see that the data type of this variable is int, which represents integer. Now if I change the value to, let's say, 5.6, so what will happen? The data type of this variable will now change. Notice it becomes float. And similarly, if I change it to text, and remember, whenever you are providing text to a variable, it has to be in quotations. So if I say PYP002, this is text I'm assigning to the variable var, and I'm printing it again. So if I run this one now, you will see the data type of this variable changes to string. So variables can have these 3 different data types. They can be text, they can be integers, they can be floating point numbers. Now if we go back to our initial very basic algorithm where we calculate the average of 2 numbers. So here notice the average calculation step is very simple. We can say num1 plus num2 whole divided by 2. To display the average, we can use the print command. And notice the start and stop points. This is the advantage of Python. You don't need to write explicitly any start and stop points. If we are doing programming in, let's say, in C, if we have to start with int main, we have to put the parentheses, we have to put the curly brackets, and then do our work. And then to stop the program, we have to do return space 0 with the semicolon, and then we have to provide the closing brackets, and this will be the area where I will write my program. So but here in case of Python, you don't need to explicitly define the start and stop points. We saw how we can calculate the average, and to display the result we can use the print function. But the only thing left is, how can I get input? So here in the example that I have given you, what I am doing is I am already assigning a value to these variables, but I don't want that. I want the user, just like a calculator, when you turn it on, the calculator is waiting for you to type a number. I want the same thing. I want the user to type the input for the variable. So here, if you notice, in the very basic algorithm, we have 2 input variables, num1 and num2. So I want to get their inputs. So to do that, we can use the I can say, let's say this is the num1. I can use the function which is the input function. So this input function, I can provide a message. I can say, okay, enter first number, and then let's see what number we receive. So here if I run this, it will tell me to enter the first number. So if I type, let's say 74, so it will receive this number and print the number, but there will be a slight problem with this. The problem with this is that if I go to the variables, you will notice that the num1 variable here is of type string. Although I typed a number, but this input function, what it will do is it will receive the input in the form of string or text. Now what we need to do is we need to convert this text into a numeric form, and we can decide based on the data type. So here whatever input I receive, by default in Python there are functions with the name of the data types. I can say equal int, and sorry, not equal, so I can say int, and in the brackets I can provide text here, and the function will try to convert the text into an integer. Similarly, I can put float here, it will try to convert the text into a floating point number, so or which is basically real numbers. So what I can do is here the whole thing, this is giving me text, so this whole thing I can put it here, and that will give me an integer number because it will convert it to int. Similarly, I can do this, I can say float, but inside the float function input I can provide this one here. So the input function will get the number, it will be in the form of text, but the float function will convert that text into a real number. So here let's do it with floats. So here if I do this, if I put all of this inside the float function, and now if I try to print the number, you will see I'm getting a delay. So let's wait, let me refresh it. So here notice, so if I run this, it is going to ask me for the first number, and if I type 78.5, it's going to display 78.5. and but now if I check the variables, you will notice the num1 is now a float variable, which is real number. So I can do the same thing to get the second input, let's call it num2, and here I can change the message, enter second number, and now I can calculate my average, which will be equal to, in the brackets, num1 plus num2 whole divided by 2. And once I have the average, I can print the result. I can say print the average value, and this will give me the answer. So here if I enter 78.1 and second number is 45.5, it will give me the average 61.8. But notice here it's only giving the output in the form of a number, it's not displaying any message. What if I want a message? I want a message like this, it says the average is equal to whatever value I have calculated. So what I want to do is, in the print, in the output print, I want to combine the average variable with the string text or the text input. So to do that we can use commas. So I can put a comma before average, and before the comma I can provide text here, and to provide text I can use the quotation marks, and here I can say the average is equal to, after the comma I can provide the name of the variable. So now what will happen if I run this? It will display the average is text first and then display the value. So here if I enter the first number 78, second number 98, it will now say the average is equal to 88. So that's how you can basically convert an algorithm into a Python program. We get the inputs using the input function and we display the results. There's another way which uses the plus symbol, but it is a little more complex. We'll just use the comma separator to separate the text from variable. That's the easiest way. Now we got the input. Let's see. Okay, so let's talk about the arithmetic operators that are in Python. We have the basic addition, subtraction, multiplication and division. For division, what it will do is it will calculate the let me show you like this. So if I do 9 double forward 6, so if we do 9 divided by 6, we will get the answer 1.5. but what the double forward slash do is it will convert the real number value into the previous integer that we can get. So for example here 1.5, the integer before that is 1, so the answer of this will be 1. Similarly, if I do this, let's say 9 divided by, let's say 5, so in this case, no, that's not the date, so if I do 9 double forward 5, so in this case 9 by 5, the value should be 1.8, but due to the double forward it will do the floor division and it will give me still the answer, that is 1. So that is called floor division. Next we have what is called the remainder operator. Using the percentage sign we can calculate the remainder. So the remainder, basically what it will do is, if I do the same thing here, we have 9 which is divided by 6, but this time it will do integer division. That means we cannot use any decimal points. So I will get 6 ones is 6, 9 minus 6, I am left with 3. I cannot divide 3 further with the 6 number. So in this case 3 will be my remainder value. So 9 percentage 6 will be 3. Similarly, if I do, let's say 75 percentage 10, so 10 7 is 70, 75 minus 70, I will be left with 5, so the remainder is 5. And similarly we can do in this way 10 percentage 20, I cannot divide 10 any further, so the remainder is 10 itself. So we have the remainder operation, floor, and we have exponentiation also. This basically calculates the power. So here if I do this 2 double multiply 3, that will be 2 to the power 3, that will give me the answer 8. So that is how different mathematical operators they work. But besides that, we also have what is called some extra modules in Python which contain a group of functions inside them, and those modules, they can be imported using the import keyword. So in my Python program, what I can do is I can create another block, and here if I do this import math, so this math module contains many functions inside, and whenever I want to use them I can use the name math dot the name of the function. So here you see there's a list of all the functions which are available inside this. So we have is infinite, is not a number, we have the floor function also, factorial, we have the fab, we have the exponential function, there is cosine, sine, log function. So there are many functions available in this math module which we can use. So we have sine, cosine, tangent, we have radians which convert angles from degrees to radians. And remember, in C language, in Python, in Excel, all these trigonometry functions, their input is required to be radian value. So you need to convert. If I have an angle in degrees, I need to convert it to radians and then give the input to the sine function. So based on that we can check here. So you see 2 times 2 double multiply 3, that means 2 power 3 will be 8 plus 4 divided by 2. Division will occur first instead of addition. So that will give me 4 by 2 is 2. So 8 plus 2, 10. That will be the answer. Similarly here you can check the values of these different calculations. 4 times 3 is 12. 2 times 8 is 16. 4 power 2 is 16. So 16 by 16 will give me 1. 12 plus 1 will give me 13. Ceiling is another function which is the opposite of floor. Floor converts any real value into the previous integer. Ceiling converts the real value into the next positive integer. So ceiling 7.1 will become 8. Floor 7.9 will become 7. So here You can calculate this one, 13 minus math dot ceiling 19 divided by 4. So that will give me the value 5, and 13 minus 5 will give me the answer 8, plus 4 to the power math dot floor. 5 into 0.5 is 2.5, and 2.5 when I take the floor will give me 2. So 4 power 2 is 16 plus 8, that will give me the answer 24. And similarly we can calculate these equations also. I will just do one of them just to show you. So first notice we need the sine function, here we need the square root function, also the cosine function. So what I'm going to do is I'm going to import the math library, but I can also do another trick. I can do this, I can say import math as m. So what I will do now is that whenever I want to use the math module, instead of calling the full name math, I can use the short name, which is m. So this will be useful. So here we have to get x and y, which are real number inputs. So I can get it from here. I can just copy this one, change this to x, change this to y. So here I can say enter x, and here I can say enter y. So once I have the two inputs, now I can calculate my outputs. So our output 1 will be equal to this equation, that is 8 plus, in the brackets I have to calculate sine of x over y minus 5. So I can see m dot sine of x. M dot sine of x divided by, I cannot directly put y minus 5 because it will only divide by y. So I can put brackets y minus 5. So this will be my second part of the equation, multiplied by 9. So I will multiply this whole thing by 9. This will be my first output. Similarly, my second output I can calculate, that will be 13 plus x power 5. So I will put it in the brackets 13 plus x double multiply 5 whole divided by square root of y plus cosine x. So the square root function is in the math module. We have m dot sqrt. So inside the sqrt I can provide the equation, which is y plus cosine x. I will say here y plus cosine of x. And once again, for using the cosine I have to use m dot cosine x. So once I have done that, I can print the results. I can say that okay, output 1 is equal to comma, I will say the variable out1, and then I can print on the second line output 2 is equal to the variable out2. So in this way I can calculate the value of those two equations. If I give x as, let's say, 5 and y as, let's say, 10, I will get output 1 6.27 and output 2 978. So this is how you can calculate these equations. And another thing is we can include comments in Python using the hashtag symbol. So the comments, they help us understand the code easily, and also later on whenever we want to debug or whenever we want to find errors, it will be easier if the code contains comments. For example, the same program that I have written here, I can provide comments here with the use of hashtag. So anything written after hashtag is not part of the code, it is just explanation, it is just description. So here I can say I am importing the math library here. In the second step I am saying that okay, hashtag getting the inputs x and y. Similarly here I can put the hashtag I am calculating results here. And then at the end, the last step, what I am doing is I am displaying the results. So the comments, they help us in describing or giving explanation for the code, which can later on help in debugging our code as well. One more thing to note here is that all the keywords that I am using here, like import, the word as, the float keyword, the input function, the print function, all of them, they are in small case letters because Python is case sensitive. If you change it to capital P, it will not work. So you have to be very careful. All the letters that you see here, they are in small case letters, and you have to be careful whenever you are coding in Python. Another type of variable we can have in Python, that is called the list variable. So this type of variable basically contains a group of other variables inside. We call that a data structure. So here I can define a list which is equal to, I can define it inside a square brackets. It can be a list of numbers. Okay, so here if I try to print this list, so this is the result that I will get. So this is a list of numbers. I can also define a list of real numbers and the normal integers. So a list can contain real numbers, integers, or I can put here text also. I can say PYP002. So now this list contains a collection of floating point numbers, the real numbers, it has integers, it has text also. If the list contains the same type of numbers like all integers or all real numbers, we call that list an array. And the list variable, they are indexed starting from 0. Remember I told you, whenever we declare a variable, whenever we create a variable, its block is created in the memory. So for example, if I create a variable, its block will be named, let's say, X. But in case of list, we have a collection of variables. So whenever we say I created a list, let's say list, this is the name of the list, and it contains, let's say, 5 variables inside. So each variable is indexed starting from 0, 1, 2, 3, 4. To access a specific element of the list, we can use the name of the list with the square brackets, and inside I can provide the index. So for example, here I have a list which is temp. These are the inputs and they are indexed from 0, 1, 2, 3. So if I say temp 1, that means I'm accessing the element 15 here. So based on that, we can do very simple calculation, that is we can calculate here. The initial values are 35, 15, 45 and 28. So when I see temp 2 plus 6, so let me write them down here. So this one is 35, this one is 15, the next one is 45, and then we have 28. So when I do temp 2 plus 6 here, temp 2 means 45 plus 6 is 51, will be the new value of temp 0. So temp 0 becomes 51. This is the new updated value. Temp 3 is temp 3 divided by 4. Temp 3 is 28. When we divide it by 4, we get 7. 7 is the new value of the fourth element of the list. So here this will change to 7. And then temp 2 is temp 1 divided by 3. Temp 1 is 15. When we divide it by 3, we get 5. So temp 2. So temp 2 is here. That will be given a new value, that is 5. So this is how you can change the values inside the list. I'll stop here, and in the next video I will give you explanation about conditional statements.